Good morning and hello viewers. I'm sorry to be back after a pretty long time since I last uploaded a video for the children of grade 11 and 12 and those preparing for different types of examinations with chemistry as one of the subjects involved in it. This video deals with equivalent weights and a few problems in the later part of the series. First, we see the definition. The equivalent weights, they are not equal. The equivalent weights are not equal. That should be drilled into our minds at the outset. Equivalent weight of a substance is the number of grams of the substance that will combine with or displace directly or indirectly 1.008 grams by weight or by weight of hydrogen, 8 parts by weight of oxygen, or 35.5 parts by weight of chlorine. Now, the substances and compounds are categorized differently. Now, some of the categories are shown here. We have salts, we have acids and bases, we have oxidizing agents, we have reducing agents, and we have elements, and we have cations, and we have anions, you see. So many types. We have taken broadly everything here, and we shall see how in each case the equivalent weight is calculated, the formula involved in calculation of equivalent weight pertaining to salt, acids, bases, oxidizing agents, reducing agents, and elements. The equivalent weight of a salt is given by its molecular weight divided by number of electrons exchanged. So naturally, the covalent compounds in which the electrons are shared will not be covered by this in theory. But if we if we take into account that the electrons are displaced more towards the electronegatively charged element or the more electronegative element, then we can apply this in part and this will work well for covalent compounds as well. So the equivalent weight of a salt, which is formed by exchange of electrons between the metal ion and the non-metal anion, is its molecular weight divided by number of electrons exchanged per molecule. The equivalent weight of an acid is given by its molecular weight divided by number of replaceable hydrogen ions that it gives in solution. The equivalent weight of a base is molecular weight divided by number of replaceable hydroxyl ions, that is the OH ions. The equivalent weight of an oxidizing agent is given by its molecular weight divided by number of nascent oxygen or oxygen atoms released per molecule. The, the equivalent weight of a reducing agent is the same as this molecular weight of the reducing agent given by or divided by number of hydrogen ions released per molecule. An equivalent weight of an element is equal to atomic weight divided by its valency. Equivalent weight of an anion like CO3 2- will be given by the molecular weight, that is the combined weight of carbon and oxygen in it, divided by number of charges that it has. So it will be, for carbonate, it will be 48 divided by 2, it will be 48 plus 12, 60 divided by 2, 30. So that is what is the equivalent weight calculation for different types of compounds that we encounter while learning chemistry. Example here. This is an oxidizing agent. KMnO4 is an oxidizing agent. It reacts with sulfuric acid to give K2SO4, MnSO4, and 3H2O, and 5 oxygens. The molecular weight of KMnO4 is found by adding up the weights, atomic weights of potassium, manganese, and oxygen, and it comes up to 158. Sorry, 158, and it is divided by this 5 oxygens, and it is 31.6. Remember, there is no gram. Equivalent weight has no unit. Similarly, if we use another oxidizing agent, K2Cr2O7, and the reaction is with sulfuric acid is K2SO4 plus Cr2SO4 whole thrice and 4H2O, and finally 3 nascent oxygens are given. So the equivalent weight of K2Cr2O7 is the atomic weights of K, Cr, and O added as they are in this formula, that is 294 divided by 3 nascent oxygens, and it turns out to be 98. There's another relation between the metal salts that upon heating give metallic oxide, like lead nitrate, zinc nitrate, calcium carbonate. They're all salts which upon heating give a metal oxide. So the mass of metal salt divided by the mass of metal oxide that it produces is given by equivalent weight of metal plus equivalent weight of anion, just like we found out the equivalent weight of carbonate, and the two are added up and divided by the sum of the equivalent weight of metal and equivalent weight of its oxide, as it is given here. Let's go to some other problems. So find the equivalent mass of H3PO4 in the following reaction. And the atomic weights to be considered are given here. H equals 1, P 31, and O 16. The reaction follows this path. Calcium hydroxide reacts with phosphoric acid to give calcium hydrogen phosphate and 2 molecules of water. Remember, only 2 hydrogens have been substituted, not all 3. The solution, molecular mass of H3PO4 is found by adding up the masses of the number of atoms involved in one molecule. So that is 3 hydrogens, 1 phosphorus, and 4 oxygens, working up to 98. Since only 2 hydrogens are replaced, so it is 98 by 2 equals 49. Now, another problem 42.15 gram of metallic carbonate was heated in a hard glass test tube, and CO2 evolved was measured at 1336 or 1336 ml at 27 degrees and 700 mercury pressure. What is the equivalent weight of the metal? Two calculations will have to be done. First, we will have to convert this volume obtained at this temperature and this pressure to temperature and pressure at STP. Very essential. So the mass of CO2 must be found out first, and that is why we have to apply this formula. P1V1 divided by T1 equals P2V2 divided by T2. So we have now P1V1 by T1. This is your STP values. So therefore we have 1336 into 700 divided by 300. 300 we get by adding 27 to 273. That is the conversion method of centigrade to Kelvin scale, which equals 760. The P2 is 760. So this is P1 V1 T1, and it is converted to P2 V2 and T2. We don't know V2, so we substitute P2, which is 760 mm at STP, and 273 also at STP. And we get V2 as approximately 1.120 liter at STP. Now, mass of 22.4 liters carbon dioxide is 44 grams at STP. So 1.12 liters will be 1.75 grams. Equivalent weight of oxide is 16 divided by 2, which is 8. Mass of metal oxide is found by subtraction, because this much of carbon dioxide has left. So the mass of metal carbonate that we started with has reduced to metallic oxide, which is so much. An equivalent weight of carbonate is equal to molecular weight by number of charges, which is 60 divided by 2, and that equals 30. So that equals 30. Now these values, when substituted into the formula which was just done in the previous slide, will give us the answer. So that is left to you to get on with the problem of solving the numerical and getting the final answer. Now, something that directly extends from the calculation of equivalent weight, and when such salts whose equivalent weight is known are dissolved in 1 liter of solution, a known weight of that substance which is dissolved in 1 liter of solution gives its normality. When molecular weight or molar mass is added to 1 liter of water, gives molarity. Similarly, when equivalent mass, when added to 1 liter of or added to water to make 1 liter of solution, gives its normality. So the normality of any solution is the number of equivalents, that is the number of equivalent weights of solute dissolved per liter of the solution. So N mathematically equals number of equivalents divided by volume in liters. The number of equivalents is the weight of a solute divided by its equivalent weight. So we have number of equivalents replaced by weight of the solute divided by equivalent weight, volume in liters remaining as it is in the equation above. Or by transposition, we have weight of solute, the weight of solute, which is equal to NEV in liters. If I take this liters out, I can put a bar here divided by 1000. That will be converting volume in centimeter of ml into liters, right? So we can write NEV divided by 1000. If the volume is already in liters, there is no need of this figure 1000. And if we do that mistake, the answer will be, see, 1000 times less. And that is not wanted by any one of us. So one equivalent weight of a substance is called one equivalent. One equivalent. So we go to another slide and we see what lies ahead. Some problems on molarity, because this is, you see, often connected with the normality. So such problems come. They may be individually based on molarity or molality or equivalent weights or equivalent weights and molarity. So molarity is the number of moles of a solute dissolved in a liter of solution. Mathematically, M is equal to N, which is number of moles divided by volume in liter of solution. N is equal to weight of solute divided by molecular weight and abbreviated as W by capital M, small w by capital M. So when we substitute, we get M equals W by M into 1 by V in liters. And finding out the weight of the solute required to make such a solution, we have W, M, M, V in liters. So we have molecular mass into molarity into volume of the solution. We have some problems here that will make the application of the formulas clear. Calculate the mass of solute in the following solutions. We have 100 centimeter cube of N by 10 KOH, and the molecular weight of KOH is 56, as you can see. We have second 250 centimeter cube of NH2SO4. The molecular weight of H2SO4 is 98, as you can see. We have 250 centimeter cube of 2MHNO3, 63, and the 63 is the molecular weight of HNO3. And the fourth is 150 centimeter cube of M by 2HCl, which is 36.5. It's 36.5 grams per mole. Let's see the answers. So mass of KOH is 0.1 into 56, which is the molecular mass, and this is the normality, and this is the volume in liters. So we have 0.56 gram KOH. Equivalent weight of KOH is 56, so we have taken equivalent weight here. Divided by 1, because 1 electron is exchanged from potassium to hydroxide, or this hydroxyl ion. Mass of H2SO4 required to make the solution, which is given in the previous slide, is 1. 49 is the equivalent weight of H2SO4, and the volume converted into liters is this. So it is 49, 49 ones are 49, and this cancels with this 1 by 4, so it is 12.25 grams of H2SO4 required, and we are using this formula for this. These were based on this, and for these we have here. So mass of HNO3 is 63 into 2, and the volume in liters is 250 divided by 1000, so it is 1 by 4. 31.5 grams of HNO3 are required to make 250 centimeter cube of 2 molar solution of HNO3, and we are using this formula in this, and we are using NEV is equal to W in this. Using weight of solute equals NEV, which is written here. This is used for these two, and this formula is used for these two. So mass of HCl, which is 36.5 gram as shown earlier in the previous slide, into M by 2. M by 2 means 1 by 2. So molarity is half. And 150 converted into liters is 150 divided by 1000. So that is 36.5 into 1 by 2 into 0.15, which works up to 2.7375, which can be rounded off to 2.74 grams. So these were some problems which will help you to understand where to apply this formula and where to apply this one. Going ahead, we have some more. Now suppose a solution of calcium chloride is prepared by dissolving 111 gram of it in 2 liters of solution. Normality of this solution will be molecular mass by number of electrons exchanged between calcium and chlorine. 2 chlorine atoms is 2, so molecular mass divided by 2 is 55.5. Normality of this solution is weight of the solute, which is 111, divided by equivalent weight, which is 55.5, and volume is 2 liters. So when we do this, we get 111 divided by 111, which is 1. So normality is 1. The of the solution is given by the same. Here it becomes 1.5. So 111 divided by 111 is 1, into half is 0.5. See the relation between normality and molarity for the same volume of solution. 1 is to half. Now from here we can get to this formula. Normality into equivalent weight. So normality is 1, equivalent weight is 55.5, which is equal to molarity. Molarity is 0.5 into 111, which is again 55.5 on either side. So that proves, that calculation proves that the formula normality equals equivalent weight, normality into equivalent weight, equals molarity into molecular weight. So knowing this and knowing equivalent weight, normality can be found out if molarity and molecular weight are there, or even if the substance is mentioned and atomic weight is given. So all four can be found out from this formula. Very important formula. So this is important. This is important. So let's see some more. Now ferric chloride, we have molecular weight divided by 3 because valency of iron is 3. Electrons exchanged between iron and chlorine are 3. In FeCl2 it is 2. So we have different equivalent weights in both these cases. Aluminium chloride is molecular weight divided by 3. Now this formula is applied only to ionic compounds. This formula is applied only to ionic compounds. So Fe2 plus is 56 divided by 2, which is 28, and Fe3 is 56 divided by 3, which is 18.67. Now, transition elements, you see, iron is a transition element, and transition elements, we know they show variable valencies in different compounds or different oxidation states in different compounds. And therefore, we can summarize that transition elements show variable equivalent weights. So finally, we have weight equals MEV, V in liters from normality, W equals MMV, V in liters, this is from molarity, and NEV is equal to MMV. If the volumes are same, then VL cancels out. So ME is equal to MM, which we just derived in the previous slide, and we have it here also. So you can calculate molarity also, you can calculate normality also, you can calculate equivalent also, you can calculate molecular weight also from this formula if other three are given. And I hope this suffices your needs for class 11 chemistry and its calculation. So let's hope that you will use this information and a little bit of working that I have shown in different slides to your betterment. And if there is any problem, you can revert back to me on my channel. But do subscribe, like, and comment. Thank you for watching. And this is another problem. What is the molality of a semi-molar NaCl solution if the density of the solution is 1.16 grams centimeter cube? So a little bit of work here. Semi-molar NaCl is half mole NaCl dissolved in 1 liter of solution. So that means it is 0.5 molar. And number of moles is 58.5 divided by 2, you see, which is 29.25 grams, you see, for the solution. Density is 1.16 gram per centimeter cube multiplied by 1000 to convert grams into kilograms and this into liters. So you see it is 1160 gram per liter. I haven't used kilograms here, converting gram into centimeter cube from gram into centimeter cube into gram per liter. Now this means that 1160 grams or 1160 grams of NaCl solution contains 29.25 grams of NaCl. It's calculated here from this molarity. Therefore, the mass of water is 1160 minus 29.25, which is the weight of NaCl, that is 1130.75 grams, and divided by 1000, it comes up to 1.13 kg. So we have 1.13 kg. So we have 1.13 kg of water involved in this. Molality is given by number of moles, which is 0.5 divided by kg of solvent, which is 1.13 kg. So 0.5 or 0.5 divided by 1.13, which is actually 0.4424 m molality, molal, or rounded off to 0.44 moles. For a given solution, the value of molality is greater than molality. And this we have to remember. This we have to remember. Thanks a lot for watching this. You can do some harder problems based on this with a great degree of ease. And let's hope you start doing the problems. If there is anything which is difficult, you can always refer it to me on my channel. Now, HCl containing 38% by mass find molarity if the density is 1.19 gram per centimeter cube. So we have what volume of HCl is required to make 1.0 liter of 0.1 m HCl. So if 1 liter of HCl solution is taken, its mass will be density into volume, so 1.11 into 1000, which is 1190 grams per liter. 38 divided by 100 into this is equal to 452.2 gram HCl in 1190 gram HCl solution. So moles of HCl is of HCl divided by molecular weight, which is 12.38 or 12.38, sorry, divided by 1 liter, which is 12.38 molar solution. The second part, using the formula M1V1 equals M2V2, we have 12.38 into V1, which is 0.1 into 1, or V1 is equal to 0.008 liters or 8 centimeter cube, multiplied by 1000, which is 8 centimeter cube. Question number 2. Calcium carbonate reacts with HCl according to this equation. According to this equation, the molar ratio is 1:2:1. The molecular weight of calcium carbonate is 100 gram. So 100 gram calcium carbonate equals 1 mole. 1 gram calcium carbonate is 0.01 mole. Molecular weight of HCl is 36.5. Therefore, W equals mmV. We have 0.9 gram HCl. That's the weight of HCl given. The mole of HCl is 0.9 by 36.5, so that's 0.02. Now, 0.01 mole calcium carbonate requires 0.02 mole HCl, which is 1:2, which is the same ratio as this. Now, the moles of CO2 according to the ratio above is 0.01 mole CO2. Therefore, volume of CO2 is this into 22.4 equals 0.224 liters. So what volume of calcium carbonate, carbon dioxide is evolved when 0.1 mole of calcium carbonate is reacted with